Hey guys, today we're going to have an introduction to angles. First of all, how is an angle formed? An angle is formed by the rotation of a ray. This is right here, this ray, this is what we're going to start with. So this is the initial side. And we're going to rotate that about the vertex. So it'll be the center of our rotation. When I rotate it, I have a new ray. The image of that original ray is called the terminal side. And between the initial side and the terminal side, we have an angle. Okay, some things about angles in a coordinate plane. When an angle is in standard position, first of all, the vertex is at the origin. The vertex is at 0, 0. The initial side is the positive x-axis. The direction of an angle. First, counterclockwise, is a positive angle. Okay, so a positive angle rotates that way. Starting on the positive x-axis, rotates that way, counterclockwise. Clockwise is a negative angle. So if an angle measure is negative, it starts on the positive x-axis and rotates that way. Coterminal angles are two angles, two angle measures that rotate to the same position. So there'll be different numbers, but they'll rotate to the same spot. Those measures are always 360 degrees apart. So it'll be one number plus or minus 360, or some multiple of 360. So an example of a 40-degree angle. That's positive, so that's going to rotate counterclockwise. So in standard position, there's the vertex at the origin, and there's the initial side, and positive rotates this way. So 40 degrees would look about like that. Negative 40 degrees, standard position still has the vertex at the origin, still has the initial side on the positive x-axis, but it rotates clockwise. So negative 40 degrees looks about like that. Coterminal angles. So let's consider this 40-degree angle here. A coterminal angle might go all the way around and then another 40 degrees. So we still have this 40 degrees here, but the angle is actually 360 plus 40. So that's actually a 400-degree angle. So 40 degrees and 360 degrees are coterminal because they end, 40 degrees and 400 degrees are coterminal because they end at the same place. They're 360 degrees apart. It could be 360 times 2 apart. Let's consider this negative 40-degree angle. Let's go around clockwise one time. Let's go another time, and then another 40 degrees. So I still have this 40-degree angle right here, but I actually went all the way around twice. So that would be 40 negative 40 minus 360, which is negative 400, minus another 360, and that's negative 760 degrees, and it ends at the same spot as this negative 40. So negative 40 and negative 760 are coterminal angles. Reference angles are always between the terminal side and the nearest horizontal axis. And they are always given as a positive number. So an example, we'll just continue with our 40-degree angle. The standard measure of that is 40 degrees. The reference angle is the number of degrees from this terminal side to this nearest horizontal axis, which also happens to be 40 degrees. Let's say I rotate 120 degrees. The standard angle measure here is 120 degrees because that's how much I rotated. But the reference angle is this right here. The number of degrees from the terminal side to the nearest horizontal axis. To find that, had we gone all the way, we would have been at 180 degrees, and I need to subtract that 120. 180 degrees minus 120 degrees is 60 degrees. That is the reference angle, 60 degrees. Let's make a standard angle of 225 degrees. So that's going to be out here in the third quadrant. So there's my standard angle. My reference angle is this right here. How many degrees is it from the nearest horizontal axis to that terminal side? And in this case, I can subtract this 180 right here from the 225. 225 minus 180 degrees. And that is a reference angle of 45 degrees. How about one that's 330 degrees? So the standard angle is 330 degrees. What's the reference angle? That's this one right here. And I can get that by subtracting 330 from 360. 360 degrees minus 330 degrees gives me a reference angle of 30 degrees. All right, now let's talk about angle units. There are two different ways to name your angles by units. There's decimal degrees. That's what we're used to. A degree is 1/360th of a circle. A degree is 1/360th of a circle. That's why there's 360 degrees in a circle. In decimal form, decimal degrees, you might see something like, in decimal form, you might see something like 7.329 degrees. One that we use a little less often is degrees, minutes, seconds. So degrees, minutes, seconds. So a degree is 1/360th of a circle, and a minute is 1/60th of a degree. A second is 1/60th of a minute. So in degrees, minutes, seconds, you might have something like 5 degrees, 11 minutes, 59 seconds. You can have decimals here in the seconds, but you'll never have decimals in the degrees and minutes. So here in example 5a, I've got decimal degrees, and I want to change that to degrees, minutes, seconds. So here's how we do that. It's 12 degrees. I just have to figure out what that 0.875 is in minutes and seconds. Here's how I do that. 0.875 times 60 is the number of minutes. So that's 12 degrees, and 0.875 times 60 is 52.5 minutes. Okay, now I need to take that minutes, that decimal within the minutes, and turn that into seconds. So it's 12 degrees, 52 minutes, and 0.5 times 60 seconds. So we have 12 degrees, 52 minutes, and 0.5 times 60 is 30 seconds. Which happens to be exactly what we have here in B, so we're going to use that same degree, minutes, seconds and convert it back to decimal degrees, so we should end up with 12.875. And here's how I do that. I have 12 degrees plus 52 60ths of a degree plus 30 over 60 squared degrees. And I can type in my calculator 12 plus 52 divided by 60 plus 30 divided by 60 squared, and that is going to give me 12.875 degrees. All right, find the measure represented by each rotation. 2.4 rotations clockwise. The clockwise is negative degrees. 2.4 times each rotation is 360 degrees. That is negative 864 degrees. 7.3 rotations counterclockwise. Counterclockwise is positive, so 7.3 times 360 degrees per rotation is 2,628 degrees. Find an equation for all coterminal angles, then find a positive and a negative example. So a coterminal angle is plus or minus 360, so what I can do is 87 degrees plus 360 times, and we use K as a variable degrees, and that can be positive or negative. Some integer, though, that K has to be an integer because if it's a decimal, I won't be at a multiple of 360. So I have to write where K is an integer. And the easiest numbers to put in there are 1 and negative 1. So if I put in a 1, it's 87 plus 360, and that's 447 degrees. That's a coterminal angle. Another So for my negative example, I could put in a -1, and that's 87 minus 360, and that's negative 273 degrees. So there's my positive and negative coterminal examples. For B, negative 123 degrees plus 360 times k degrees. And again, k has to be an integer, where k is an integer. So there's my equation for all positive, or for all coterminal angles. A positive example, I'll put in 1 for 360, or for k, so it's negative 123 plus 360, 237 degrees. And then I'll put in -1, negative 123 minus 360, and that's negative 483 degrees. And I have a positive and negative coterminal example. And lastly, given the standard angle measure, find the reference angle. So 913 degrees. What I can do is subtract 360, and that's going to give me 553 degrees. I can subtract another 360, and that's going to give me 193 degrees. So what I've found here is the lowest positive coterminal angle. Now I want to find the reference angle. So 193 degrees is going to be somewhere in this range right here. And if I do 193 minus 180, that leaves me with 13 degrees, and that is my reference angle. 167 is already between 0 and 360. So I'm going to use 167 as the reference angle. I don't need any lower coterminal. So on a graph, that would look about like that. This is my reference angle right here. 180 minus 167 is 13 degrees. That's my reference angle. And negative 290, what I'm going to do with that is add 360. Negative 290 plus 360 is 70 degrees. So that looks about like that, and that is its own reference angle.